Okay, so we've either already proven this in class or we're going to prove it next class. But this is the second part of the fundamental theorem of calculus. And I'm going to take example 1 that's kind of an explanation of what's going on here. See, what they're asking for is you have some function in here inside the antiderivative or inside the integral, but they're asking for the derivative. So essentially, we're just asking for the antiderivative of the derivative, or the derivative of the antiderivative. So these things kind of cancel each other out, but we have to think about a couple things going on here. So to explain this a little bit better, I want us to just kind of first imagine that this whole expression here, I'm going to call this f of t. And so let's just kind of go over to the side here and say, all right, so g of x equals the antiderivative of f of t, dt. And yeah, it's going from 7 to x. We'll leave those numbers in there. Okay, well, what would that be? Well, that would mean that g of x equals capital F of x, right, minus capital F of 7, whatever that is. Let's not worry about what the actual antiderivative is for now. Let's just kind of think about this conceptually, right? So yeah, we have the antiderivative of f as capital F. And so here we plugged in the x, and here we plug in the 7. But that's not what they're asking for, right? They're asking for the derivative of this. So if you were to take the derivative, that would be g prime of x equals f prime of x minus f prime of 7. Well, remember, the derivative of the antiderivative should just be this exact equation that we started with, right? It should, if we took the derivative of the antiderivative, we should just end up back with here, but instead of a t now, we should have an x. So this should look exactly like, and this is where now I'm actually doing this problem. This whole setup is just explaining how I can skip straight to here. So this would just be 4x squared minus 2x. Minus, though, what's the derivative of a constant? Remember, when we plug in a 7 here, we just get some number. So the derivative constant is really just 0. So that's really all we had to do here was just plug in an x. And there, it can get a little bit trickier than that, but that's essentially what they're having you do here, is understanding this basic concept that if you take the derivative of the antiderivative, well, then this just kind of gets replaced. But mainly because of this fundamental theorem of calculus, part 1, since this is true here, right, if we took the antiderivative, it would equal this, and then you take the derivative of this just zeroes out if that's a constant. So that's kind of all there is to it. So now as you look at practice 1, I think that you should be able to kind of figure out exactly what you can do there when you take the derivative of this antiderivative. So give it a shot, pause the video, then unpause it when ready to check your work. All right, so really all you have to think about is you're taking the antiderivative, but then you're taking the derivative, so you're just plugging in an x. You'd be plugging in an x and a 3, but the 3, when you take the derivative of it, of the function with a 3 inside, it's just going to be a 0. So really, you just get back the same function, but now with an x. That's all there is to this. It's pretty straightforward, pretty easy. So in the second part here, now they're just asking you to evaluate, and this is actually what they're going to have you do on con. It's not just do this. You're going to have to come up with the equation and then actually evaluate. So let's go ahead and do that. G prime of 2, what would that be? It'd be 4 times 2 squared minus 2 times 2. This would be 4 times 4 minus 4, or 16 minus 4, which is 12. So that's easy. Easy enough. All right, go ahead and do practice 2. I think you should be able to do that pretty quick. You may want to pause the video and just work it out real quick. Yeah, the sine of pi is just 0, so that's all there is to it. Okay, so this is just a real easy example of the fundamental theorem of calculus part 2. Where it gets a little bit more complicated is when we actually put some function in our notation. Now we have to think about this because, yeah, we're still just taking the derivative of the antiderivative, but when we take the derivative, we have to account for a chain rule. So we have to think about the fact that, yeah, we're just going to replace this function in for that variable there, but we're also going to have to multiply it by the derivative of that function. So let me show you what I mean here. Again, let's work it out like in actual math notation, and we'll say that this, my little arrow there sucks, but let's just call this f of t. And what that means then is that g of x equals the integral from sine of x or from 5 to sine of x of f of t dt. Well, when we take the antiderivative, then we know what this is going to give us. This is going to give us capital F of sine of x minus capital F of 5. And remember, this is not actually what they want. This just explains how we can reasonably write what they want. They want the derivative. Well, the derivative is pretty easy to calculate. Derivative, we'll just call that f prime sine of x. But what do we have to think about? We have a function inside of a function, so we have to think about chain rule here. So the derivative of sine of x is cosine x, so we have to multiply this by cosine x. And here, this is just a number, so the derivative of this thing is just 0. That's it. So that's pretty straightforward. Now we can think about what this would look like when we plug it back into our function, and it would be just 3 times sine x. So g prime of x equals 3 times sine x and times the derivative of the inside, which is now cosine x. Okay, so that's the only thing to remember, is that if you actually have a function instead of just an x there, you have to think about the chain rule. I mean, essentially, we kind of could have thought about it up here, but that would just, the chain rule would just be 1. We'd just be multiplying everything by 1, so nothing changes. So go ahead and give practice number 3 a try. Pause the video and then unpause it when you're ready to check your work. Well, essentially, all you're going to do is just plug in the x squared for t squared, so that gives you x squared squared. But then remember, you also have to think about the derivative of x squared, because you took the derivative of the antiderivative. So after you plugged in the x squared, so the derivative of x squared is 2x, so you just slap a 2x in front. And that's it. That's all there is to this. It's actually a pretty easy idea once you recognize the pattern here. Some curveballs they might throw you is they might actually give you an x in both of these. And we'll talk about in class what to do there. But basically, you're essentially doing the same thing that we kind of talked about here, but now when you take the derivative, now you wouldn't get a 0 because you'd have another function here. So yeah, we'll talk about that in class, but that's really all there is to it. We'll see you guys in the next video.